on worksheet 4.2, but what I want to do is look at problem number 4 and not problem number 5. And I'm going to expect you to get to this point, and I'll let you get there just so you can practice that. But I want to show you how we can take this augmented matrix and put it in row echelon form, because your calculator won't do it for you. Symbolab will, but your calculator will not. Symbolab is a miracle worker. But what I want to do is I want to show you the row operations that you would perform or could perform to get this into row echelon form. So on this problem, what I would do is I would take and multiply negative I over 3 times row 1 and add it to row 2 and replace row 2. Okay? That seems like a lot, but let me show you what that looks like. If we take and multiply negative I over 3 times row 1. All I'm looking at is row 1 just to start with. What we would get if we multiply these would be positive 3i squared over 3. I would never write all that. I just want you to see it. Plus 9i over 3 and 0. This is what that row would look like. Why would we do that? Why is that advantageous? Because that first term then becomes negative 1. My second term becomes 3i, and my third term stays 0. So if I take this expression, which is this negative I over 3 times row 1, and I add that to row 2 and replace row 2, my row 1 stays the same. I'm just using it as an operator to multiply. And then I'm going to add in that to row 2 and replace row 2. But if I add negative 1 to 1, we get 0. Negative 3i to 3i, we get 0. 0 to 0, we get 0. So you can get that down into a closer version of row echelon form. Do you see it? Because your calculator won't do that. Now, my next step in this problem would probably be to take and multiply. I want it to be positive 1. So I would probably at this point take and multiply row 1 by, do I need a negative? I don't need a negative. Let's do positive I over 3 again by row 1 and put it in row 1. So positive I over 3 this time. And if we do that and multiply this positive I over 3 times row 1 and replace row 1, we would end up with I over 3 times negative 3i minus 9 and 0. We would end up with negative 3i squared over 3 minus 9i over 3 and 0, which means that we end up with positive 1, negative 3i, and 0. So this matrix in its row echelon form will look like that. It gets obviously messier. Like if we have a complex number that has like an a plus bi, it gets a little bit messier, but we would deal with the conjugate pair at that point. So this is how I would turn it into row echelon form using imaginary numbers, which will come in handy on Monday. Very handy on Monday. Good so far? Okay. Can we go over the determinant of a 3 by 3 once again? Yeah? Do you remember if we want to find the determinant of a matrix, do you want me to do the actual 3 by 3?
Yes.
Okay. if we want to find, this is number 5. I'll let you figure out why we get to there. If we want to do the determinant of this matrix, remember what we do is we kind of isolate this into parts. Remember we did this with the I, J, and K? So I'm going to start with this term here. And I'm going to take that term and I'm going to multiply that by the determinant of the
blocking out part?
Yep.
Okay.
Yes. Right? And then I'm going to take and I'm going to multiply this term, 1. So it's going to be minus, and remember it's always minus the middle term, minus 1 times the determinant of, and then we use this column and this column. So we get 1, 1, 1, negative lambda. Do you remember doing that? And then, finally, we get, we take this term, this one, so it would be plus 1 times the determinant, and then we use the determinant of those two. So we get 1 minus lambda, 1, 1, and then I would need to do those determinant works. Yeah? So that's how we find a determinant of a 3 by 3 in case we forgot. Yeah? But a couple things. Don't forget when you find this determinant, probably the most or the easiest thing to forget is that that term needs to be negative. It needs to be minus whatever the number is. So don't lose that negative. The other ones were just based on the number they were. But is that enough to get you going?
Yeah.
Yeah? Okay.